Today, we're going to look at troubleshooting ovens with a schematic. We have a Samsung Electric here. This has two of the dual zone burners and two of the standard single zone burners and a warming center, as well as a convection fan inside. Then there's the standard bake and broil elements. We'll go over how infinite switches control the temperature. We'll go over some common failures and how to find them. On an oven like this, we start with a 220 volt input. The black is usually known as L1. The red is L2. They're interchangeable. The white is neutral. To get full use out of this oven, we need all three of these to have power, basically meaning between L1 and neutral, you should have 120 volts. Between L2 and neutral, you should have 120 volts. And between L1 and L2, you should have 240 volts. That's an average. 210 should be enough. Some buildings will have less, and some buildings will have more, depending on whether you are in an industrial or commercial area or residential. The voltage just has to be about right. A lot of times you'll find that you'll have 120 between L1 and neutral, but you'll have 0 volts on L2. If this has happened, the clock and the computer will work normally, but you'll get no heat. That's because the computer and the clock are powered from L1 to neutral. If you follow L1, it goes to this terminal. L2 goes to this terminal and the infinite switch. A little later, we'll go over how this switch operates. Following L1, we see that it goes this way to the infinite switch. On some ovens, we'll have up to 3 cooktop elements per burner. So it would be the small, medium, and large. On ours, we only have small and large. So we'll remove the center one. The infinite switch can supply power to either just the small or small and large burners. The power returns through the burner back to the infinite switch to the thermal limiter or temperature limiter through another switch inside the infinite switch back to L2, returning down the red wire to the outlet. Meanwhile, each infinite switch also has another switch inside that sends power through this wire all 4 infinite switches are common to this wire, which leads to the cooktop indicator. This tells us that there's a burner that's on. If this indicator is lit when these infinite switches are all turned off, one of these switches in one of the infinite switches has gone bad. It doesn't matter which one it is, any of them can turn this light on. Cooktops will also have another line running from L1 down to each burner. Through a hot surface indicator. Sometimes the oven will have one light for each burner. Other times, a single light indicating that one of the burners is hot. If this light is on, one of your burners has a thermostat that is stuck closed. A little later, we'll be going over how to check that thermostat. The path for the oven is very similar. Power comes up, L1, to the main board. On the main board, there are 3 relays: broil, bake, convection. They will each turn on one element in the oven. After the power flows through the element, it will go back to the main board, to another relay. This relay turns off the L2 power to the elements. If this relay fails, you may not get any elements lighting. If this relay fails in a closed state, you may find 220 volts at each element at all times. These relays will still turn the elements off, but be careful, there may be power here when you don't expect it to be. Let's take a closer look at one of the burners. This is a single element burner. It has power coming in on the orange line, goes around the coil, leaves this way through this pin. Then it goes through the thermal limiter, back to the infinite switch. Here you see a thermostat. It has 2 functions. The first is the thermal limiter. If the burner gets too hot, this spring will overcome and open up the thermostat, turning off the burner until it cools down. Then it will turn back on. The second function is the hot surface light. Anytime this burner is anywhere above a certain temperature, this switch will close, turning on the hot surface light, either for the burner or for all 4 burners. If your hot surface light is on and the burners haven't been on for some time and they're nice and cold, you may find that a switch like this on one of your burners has failed. The easiest way to find it is to first isolate power, remove either this black wire or the yellow wire from all 4 burners, plug it into just one, reapply power, see if the light comes on. If it doesn't, it's one of the other 3 burners that's failed. Try again for each burner until you find the failed one. Replace the burner itself. This thermostat is normally covered by a mica cover. We can test the burners using an ohm meter while the power is off. We'll find the common with 1 pin. This is the smaller of the 2 burners. This is the larger of the 2 burners. Testing this way eliminates the possibility of a bad thermostat as well. We test across the burner and we find that it's good. Test across the thermostat, find out that it's bad. Then we know exactly where the problem is. If we test across the thermostat from the common to the output of the thermostat common, we'll find that it is good. When the power is off, we can also test the hot surface light circuit with these 2 pins. They should read open if the burner is cold. The center element is just a warming burner. It has a much different reading than the larger burners. This is a very standard infinite switch. These will read either on or off. They don't have a variable resistor in them. Instead, they have a bimetallic strip which will open and close depending on temperature. If we take a look from L1 to pilot, pilot is another name for the cooktop indicator. That circuit is closed. We also take a look at the heater outlet. If we're following along, this is L1. It goes through the switch here to heater 1 and pilot. Heater 1, pilot. From the heater, it will go back through this temp limiter, which is built into the burner, back to heater 2 here, through this switch here to L2 here. If you measure the pilot, it will read closed or shorted. Heater 1 will read closed or shorted. The temperature where this bimetallic switch turns on and off is varied by the position of this knob, pushing a spring against the bimetallic switch. The tighter the spring, the hotter the switch will get before it turns off. On low, the tension is very low, and the switch can turn itself off very quickly, letting the burner not get very hot before it turns off. If you set it to high, it's mostly on and can only turn off in case of an overheat. We can test the oven elements this way. We set our meter for ohms. We'll check the bake element. We can check the broil element. All these should be tested without power. In the event that you have an oven that has failed during the cleaning cycle, you may find the door is locked and you can't get it open. The trick to this, there's a motor here. If you remove this center screw at this angle, you can push on this lever. This is the unlocked position. If it were locked, the lever would be over here and the door would not open for you. But removing this screw, taking off this rotating cylinder and pushing forward will unlock the door. If the door is locked and there's no power to the oven to unlock it, check the thermal cutout here. This has likely failed during the cleaning cycle. If your oven temperature is off by a little or a lot, you can check your oven thermistor here. The manual will usually have a chart that will tell you what this reading means in Fahrenheit or Celsius. This will tell you if the reading is way off, replace the thermistor. Hopefully you found some of this information useful. If there's anything you think I've missed, let me know. I'll cover it on a future video. Thank you.